Hey, this is Mr. Mola for lesson 6.4, exponential growth and decay. So there's lots of reasons why we would use exponential growth and decay. Most commonly is probably for money, if you're going to see how your money is growing or how you're losing money. People in DNR will use it to find populations of things. There's even one problem in here for those of you that want to be, go into the funeral home business. There's even one problem in here that talks about, how much dead bodies temperature goes down. So if you want to look at that, that's right here, exploration number 2, and see if you can figure out when the dead body's temperature goes down. So we're going to not talk about dead bodies. So we're going to do this exponential growth. So if you look here, so it starts off with y equals, so y is our final amount, a, which is our initial amount, so how much we're starting with, and then we have 1 plus the rate, and this is for growth, so that's why it's a plus the rate. And rate says always in decimal form, and then says t for time, and time always has to be in years. So if they give you something that says 18 months, you need to make that 1.5 years. And then they have pretty much the same formula here, except this is for decay. So if you notice, the only difference is it says 1 minus the rate. Otherwise, A still stands for initial amount. You still have the 1 in there, minus the rate, and then t for time. And then you'll see right here you have the compound interest formula, which is kind of the same, but it kind of adds an extra step there with the rate divided by the number of times interest is compounded. And we'll talk about that there here in a second when we get to that problem. Okay, so if you look at number 1 here, in 2005 there were 100 rabbits in Polygon Park. The population increased by 11% each year. So this is one of those DNR problems. You want to figure out how many deer are in the area or rabbits are in the area. DNR probably uses these a lot. So y equals, we have the initial amount of 100. And since it's growing, increased, we're going to use that growth formula. So 1 plus, and then 11%. And remember, it need to be rate in decimal form. So 11% in decimal form is 0.11. And we have it to the t power because we don't know how many years yet. And the only thing else that Big Ideas want you to do here is just simplify. And they're just going to want you to simplify those parentheses. 1 plus 1.11 is just 1.11. So if they ask you to write the formula, there it is. Okay, now for question B, it's asking what's the population in 2025. So kind of a trick here is the years. So some of you might want to put 2025 in the years there, but we're not going to put 2025 because we have 2005. This was the population. We want to figure it out in 2025. So our t is actually going to be 20 because it's 20 years later from 2005 to 2025. So I'm going to put a 20 in there. Okay, I need a calculator for this part. So 100 times 1.11 raised to the 20th power. And we get about 806. So we figure out that in 2025, there's about 806 rabbits in Polygon Park. Okay. 2, 3, 4, 5. We're talking about, it's just going to ask us on the table whether it is growing or decaying, and then explain. So how much it's growing or decaying by. So it could be growing exponentially with a math or with a multiplication problem, or it could be growing just steadily with an addition or subtraction problem. So let's look at number 2 here. So we're going from 20 to 30 to 45 to 67.5. So first of all, I know that's a growth problem because all those numbers are going up. Okay, they're not going up in an adding pattern because that's going up 10, that's going up 15, that's going up some fraction. So it must be a multiplying pattern. So when I have a multiplying pattern like that, I'm going to start by dividing, kind of weird, the last number, which was 67.5, by the next number. So 67.5 divided by 45 is 1.5. 45 divided by 30 is 1.5. And then we got 30 divided by 20, and that's 1.5. So very consistent here. It is growing by 1.5 every time. Here now our numbers are 160, 40, 10, and 2.5. Well, those numbers are going down, so this is a decay problem. And again, it's not subtracting problem. That's minusing 120, that's minusing 30, that's minusing 7.5. So it's not decaying by the same amount every time. So I'm going to do the same thing. So 2.5 divided by 10, okay, is 0.25. 10 divided by 40 is 0.25, and 40 divided by 160 is 0.25. So it is decaying by 0.25 each time. Number 4, we have 32, 22, 12, and 2. So again, the numbers are going down, except this time we could figure out the pattern here. It's subtracting 10 each time. So it is decaying by 10 each time. And then number 5 here, 4, 10, 25, and 62.5. So those numbers are going up, so it is a growth problem. It's going up 6, up 15. Okay, so not the same every time. So let's go to the calculator, see if we can figure out what it is. So 62.5 divided by 25. So remember, start at the bottom 2. I get 2.5. 25 divided by 10, I get 2.5. And then 10 divided by 4, and I get 2.5. So we are growing very consistently by 2.5 each time. Okay, 6, 7, 8, kind of the same thing, except now they give it to us in an equation form. So if something is at 1.00, aka 100%, that means it is staying exactly the same. So let's say example like stock market. You can lose money in the stock market, or you can gain money in the stock market. Not like your checking account that like always stays the same, or like a savings account which only goes up, but it doesn't go up by as much as it could go up in the stock market. So if something stays at 100%, it's staying the same. So 1.00. So if something is more than 1.00, that means it is a growth problem, only if it's more than 1.00. If it is less than 1.00, that means it is a decay problem, and they want us to say how much it's decaying by. So here they have a 0.95. So 0.95 is less than 1.00. So this is a decay problem. And then decaying by how much? Well, this is 100%. That's 95%. So it is actually decaying by 5%. Okay. Number 7, kind of the same thing. We have 1.08. So 1.08 is more than 1.00. So we know this is a growth problem. And it's bigger by 8%. So it is a growth of 8%. Then we got 3/4 over here, which they kind of mix it up, put in a decimal. But remember, 3/4 is the same as 0.75. So changing the fraction to a decimal. And same thing, 1.00 is more than that. So it went down. So it decayed. And from 1.00 to 0.75, it decayed by 25%. All right, so for these last two, these are compound interest problems. So we need to figure out how much money they're putting in there. Okay, so we are starting with 3,000. So let's write down our compound interest formula first before we do anything else. So for compound interest, it is y equals p, and then 1 plus r divided by n raised to the nt. Okay, so remember, we know what all these mean. P means principal, 1 means 1, r is the rate, t is time. It's this n that's the new one. And that means how many times something is compounded. So how many times are you getting interest on it? Okay, so quarterly means that happens 4 times a year. So 4 times a year you are getting interest. Okay, monthly, well, there's 12 months in a year. So that means 12 months out of the year you're getting interest. Okay, you could also have daily. That means 365. Let's not assume it's a leap year. So that means every day you're getting it. Okay, so usually it's either daily, monthly, quarterly, or yearly. That means just once a year you're getting it. So we're going to figure out these two with quarterly and monthly, and I think you might have 1 or 2 on your homework that asks about daily and yearly. So let's do these with this one. So $3,000 is what we're starting out with. And then 1 plus. Okay, our rate is 0.06. And then we are getting interest 4 times a year because it's quarterly. Okay. And then we got to put it, the t is time. And then we don't know what the time is yet. It didn't tell us anything, but we're getting it 4 times a year. And the only other thing that Big Ideas is going to want us to do here, it's going to want us to simplify that middle again. So I got to figure out what 0.06 divided by 4 is, and then plus 1. So then we could figure out now our final formula here is 3,000 times 1.015 raised to the T4 power. So if they tell us, after 2 years, then I'm going to put a 2 in there. They tell us after 5 years, I'm going to put a 5 in there. They tell us after 1 year, I'm going to put a 1 in there, and then we can kind of figure out how much money is there. Okay, same thing on number 10. So now $5,000. Switch to black ink. Same thing, 1 plus, and then our interest is 7.2%. So 7.2% is 0.072. And then we have it compounded monthly, so I'm going to divide by 12 there. And then kind of the same thing on the outside, my time, which we don't know, times 12. Okay, so you put this on the test, that's perfectly fine. Big Ideas is going to want you to simplify those, so let's figure out what that is. So 0.072 divided by 12 plus the 1 that's inside the parentheses, so 1.006. So 5,000 times 1.006, and then kind of that same thing, the 12t, or the t times 12. Okay, so then this would be our formula. So again, they tell us that, hey, it's 2 years, put a 2 in for t, and then you can solve the formula there. They tell us it's 5 years, so let's just do one just for fun to see how much your money grows. So on that one, it was 5,000, and then 1.006 raised to the, let's say, 5 years. So 5 times 12 is 60. So that means if you invest right now as 12, 13, 14-year-olds, $5,000 in the bank, and they tell you that you're going to get 7.2% annual interest, and it's compounded monthly, that after 5 years, your $5,000 is now going to become $7,158 and how many cents was it? 94 cents. So you just made about $2,158.94 by doing nothing and just having your money in the bank there. So kind of cool to figure that stuff out, especially some of you that are maybe, if you did this a couple years ago when you were maybe 11 and trying to buy a car, you have some money from birthdays, you turn 16, you're like, oh great, this is going to be great, I'll put money in the bank, and then you can kind of see what's going to happen to that money.